Hi everyone. For today's lesson, we are using the same data as we did last class. And so I went ahead and put in the values 3 out of 25, 5 out of 25, 4 out of 25, 3 out of 25, 6 out of 25, 4 out of 25 for each of the probabilities here. But before you get started, what I want to show you is how to do it in your calculator. So number one asks you to find the mean and standard deviation. And we already have this information from last class, but what I want to show you is calculator steps. So I put the directions here on the screen so you can pause and try to follow them yourself, but I'll also show you on the computer screen as well with the calculator, and you can watch as I go through it. So for the first one, you hit stat enter to get to this screen, and you put all the x values into your L1. So then into your L2, you put the probabilities, 3 out of 25. And then let me go ahead and put this over here so I can see them. You can just type them as fractions and it will convert them to the decimal for you. 5 out of 25, 4 out of 25, 3 out of 25, 6 out of 25, and 4 out of 25. And so that 6 out of 25 did not work out. Oh, that's because I put 26. And so then that should be it right there. And what you do next is you hit stat, right arrow to calc, hit enter for one var stats, and then you leave your list as L1 and then take your frequency list and hit second number 2. That means that we'll weight our x values in L1 with the frequencies or probabilities that they occur in L2. So it should look like this, L1, L2, hit calculate. And then you see we have the mean of 11.04. We use the symbol mu for this mean, but that's still the same thing. 11.04, which is what you got in class last time. And the standard deviation, 7.56, is what we got when we did it by hand as well. You'll still need to know how to use the formulas and show your work, but you can use your calculator to get the actual answers. That should make today's activity go a lot faster. We'll continue on with the activity, but just make sure you use that method to get all of the answers because, like I said, will go a lot faster. All right, so now that you have done the rest of the worksheet using the calculator, hopefully, to make it go faster, we're going to do the debrief now. So take out your red pen. First thing we have here is we just used the formula from last class. I'm not going to write that down again. What we notice on number A is we add $10 to all employees. So I'm going to say y equals x plus 10 is what we did. And so look at this mean. Mu of y equals mu of x plus 10. So that's what you should notice. And then standard deviation, no change. Remember, it's not affected by adding or subtracting. So that is what you should notice there. For option 2, we doubled it. So let's say this time y equals 2x. And so what you should notice here is that the mean, mu of y equals 2 times mu of x. And the standard deviation of y equals 2 times standard deviation of x. So hopefully you notice that. And for number 3, depends on what you started with. Also notice the probabilities never changed, and so that will keep the shapes the same, which we'll see when we do the important ideas. Next, we had a couple of things. 4 and 5 were just practice using the calculator again to get those values. And then here, we are summing 2 variables. So they have all different outcomes, and we're going to sum those together. And so hopefully you saw how these values got there. You could have a wage of $9 plus a raise of 1 or a raise of 3. So that was 9 plus 1, 9 plus 3, 10 plus 1, 10 plus 3, 11, 12 plus 1, 12 plus 3, 15 plus 1, 15 plus 3. And then this, we're using the rule from probability where we multiply probabilities together. We had to assume they were independent to do that, but we could do that. They're separate. Oh, right there it says it. So we were able to use that rule we had learned to make a new table. And what I want you to notice is that the mean, so I'm just going to write mu of x plus y equals mu of x plus mu of y. And that would be the case for a minus as well, if we add or subtract those. Because you can see here that 1.6 plus 13.45, or 1.6 plus 11.85 equaled 13.45. And then what we see here is that the variance, I think I want to remind you that variance equals standard deviation squared. And so hopefully you remember that from last lesson with Mr. Crouch or from Unit 1, but you have to know that. And so here, the variances just got added together, 4.93 plus 0.84. There's a little rounding difference, but ultimately they just got added together, but not the standard deviations. So 2.22 plus 0.9165 is definitely not 2.4. And so we don't add standard deviations together. But because we can add the variances, okay, so we don't add standard deviations together, but because we can add the variances, then the variance of two variables added together is just the variances added together. This will be true for a plus or minus. It's always addition. And then put that little note there. That means that for standard deviation, we'll just square root the variance. It's kind of like the Pythagorean theorem. So I'm just going to write square root the variance. So hopefully you see how that works. If not, you can just memorize the rules and you can use them later. Here are all the check your understanding notes about it. So go ahead and pause this to write it down. I'm actually going to zoom out so you can see it all at once. So pause this, write it down, and then try to check your understanding with this knowledge, and we'll go over those answers in 1 second. All right, here are those answers. So for A, the shapes stay the same. For B, we're using the formula that mu, if y equaled 500 times x, then the mean of y is 500 times the mean of x. Same thing for standard deviation. You just multiply standard deviation by the change. But then when we subtracted $75 from it, that does not affect standard deviation. Hopefully you saw that. And then on number 2, we were adding the distributions together. So we use those formulas where we add them. For the means, we can just add. For the standard deviations, we have to add the variances instead. So we square them, add them, and then square root that to get back to standard deviation. Now, number 3 is a little tough. We had to transform them 2 different ways at once. So one thing you could do is we already knew this value from, or this part of the value from 1C. And we could have found this ourselves first before squaring it. I just did it all at once, but you could have done it separately first. There. Okay, now we also want to go over some normal curve stuff. If you notice on your notes, it says for normal distribution problems, we have to find the new mean and standard deviation and follow the same rules we've done before. And so I do want to do this half sheet, little practice on a half sheet this time because you're at home and you can print out whatever you want. So it's just going to be a practice sheet. The way I want to do it is I want to do one with you. So this is linked in Canvas, so you can get it from there. I want to do one with you, and then we'll have you do one on your own, and then I'll do one more with you and have you do one on your own there too. So just so you know, this is Miss Braylon's dog Lola, and then Miss Pendleton's dog Mance. And so we have this picture up from years before, but I thought we should still keep it because they're both so cute. So there's our dogs. This is who was featured in this first question right here. So what you want to do, it says the amount of time Miss Braylon's dog Lola sleeps is normally distributed, put a capital N, And this is for Lola, so I'm going to do a little L for Lola with mean 18, standard deviation 2. Remember that notation from chapter 2, unit 1. Now, Miss Pendleton's dog, Mance, normally distributed. We'll use M for Mance. He sleeps 17 hours a day, standard deviation 1.5. That helps us organize everything. Assume the sleeping dogs for the 2 dogs are independent. Find the probability that Mance sleeps longer than Lola. So for Mance to sleep longer than Lola, we would want the probability that Mance's sleeping time minus Lola's sleeping time is positive. That means that if Mance slept 20 hours and Lola slept 18, it would be a positive number. And so we have to do this as a difference because that's the only rules we know. We have sum or difference rules. This can be written as a difference. What that means is I need to find a new mean for Mance minus Lola. I'll take Mance's mean minus Lola's mean and get -1. And a new standard deviation for Mance minus Lola. Now this formula is, we have to find their variances first. We'll do Mance's squared, always plus Lola's squared. And then 1.5 squared plus 2 squared, square rooted. Do that in my calculator. Square root that. And we get 2.5. Now we would always want to have a positive standard deviation. If we had tried to subtract those, we would have gotten an error in the calculator. So that's one reason why it's always plus. And then now we have a new normal distribution for Mance minus Lola, where the mean is -1, standard deviation is 2.5. That means that Mance sleeps an average of 1 hour less than Lola, which you can see from their 2 distributions, but when we combine them, that's what the negative means, because we did it in this order, Mance minus Lola. Okay, so now it's just a regular old normal curve problem, and so we're going to draw the normal curve. Our mean is -1. I need to find 0, and our standard deviation is 2.5. So to get to 0, I would go up, and it would be this right about here. And so I find the z-score. Z equals value minus mean over standard deviation. So I'll just do 0 minus -1 is +1 over 2.5. And I get 0.4. And so remember how we do all this? We have to write capital N, 0, 1 for the z-score, our standardized curve. Oh, that's so ugly. No, I can't do it. I was going to leave it, but still ugly. Okay, can leave that one. 0.4 is right where I thought it would be, up there. And then remember, we go to table A. And I'm looking for 0.4 on table A. And so, see if I can find where my table A went off to. 0.4. I got 0.6554. Remember, table A only shows you the values to the left, so that's what this area represents. I want the shaded region, so I'll do 1 minus 0.6554 and get 0.3446 for my answer. Remember, your whole answer, though, is this whole thing. So what I want you to do now is just use this problem as a guide to do number 2. And then I'll unpause the video. You'll unpause the video to check the answer. And then we'll do number 3 together, and you'll do the same thing with number 4. All right, so here's how we did number 2. I did female minus male for female being taller than the male. And then you just have to make sure you do everything in that order, female minus male the whole time. The other people could do it male minus female and get the same answer. You just have to keep it consistent throughout the problem. And that's what you get. You can pause to look over it. And we're going to do number 3 together. Okay, so number 3, we have the weights E of a single large grade A eggs from Eckland's Best are normally distributed. So I'm going to say capital N, E, with mean 68, standard deviation 5. The weight of the carton, we'll use the letter C for that, carries the eggs are also normally distributed with mean 20, standard deviation 2. Find the mean and standard deviation for the total weight of a carton of eggs from Eglin's best. So let's just write W equals, and at Eglin's best, we would be adding 12 eggs together. So egg 1 plus egg 2 plus, so the 12th egg, plus the carton. This is a sum problem because I'm combining 12 different eggs together. I'm not taking one egg and multiplying it by 12. I'm taking 12 eggs and adding their weights together plus the carton. So it's important that I write it like this. And so mu of W, it will work out that I can do 12 times 68 plus 20. But remember, when I actually were to take 12 eggs, I would be taking 12 different eggs and adding all of their different weights together. They don't all weigh 68. We just can use that as an average. And I get 836. And so that's important for when we do our standard deviation because we want to use the formula for the variance, which means I'm going to take my standard deviation of 5, square it, and add it to itself 12 times, which is how this works out algebraically, plus 2 squared. So I'm going to be doing that in my calculator. Square root 12 times 5 squared plus 2 squared. And I get 17.4356. Now that is not equal to 12 times 5 plus 2. So do not do that. You have to think about the variances. So we're adding 5 squared 12 times and then adding in the 2 squared because we're combining 12 eggs plus the carton. So we have to use the rules for addition or sum, the sum rules. Okay, so what's the probability that the weight of a carton of eggs is over 850? Hold on. I was active. iPad. Okay, so the weight is over 850. And so we're going to draw a normal distribution for the weight with 836 as the mean and 17.4356 as a standard deviation. And then if I added 14, I would get to 850. So 17 will get me there past 850. So that's right here. And then I find the z-score. And so I'll do 14 divided by the answer, 0.80. And that's my z-score. So now I'll do a z-score curve. Oh, those get bad at the bottom of my iPad. 0 and then 0.8 was about where I thought it would be, right there. And we'll look on table A. For 0.8, it's 0.7881. And so I have to do 1 minus since that's on the wrong side. And I get 0.2119. All right, so now you guys try the last one. It's another one similar to this. So try number 4 on your own, and you can pause the video while you do it and then unpause to check the answer. All right, here you go. We're adding together 30 songs. Remember, each song will have its own different length, and so we're adding 30 variables together instead of taking one and multiplying it by 30. So we have to use the sum rules for that instead. And please email your teacher if you have any questions. Hopefully this clicked. Now we'll keep practicing. Have a great day.